Tech Services gets a phone call from their field maintenance guys. The guy calls them up, says, "Hey, we're cleaning out the condenser and there's a lot more gunk than usual," and that's when alarms go off. There was a lot of communication going on within the company at this point. Engineering, tech services, management, all wanted to know what was going on. So samples were sent to a chem lab and the results came back hexavalent chromium, which is a known carcinogen. That's what the green gunk was. They told us right out that they had a theory that the phosphoric acid in the exhaust stream that they were trying to condense the water out of was reacting with the chromium 316 stainless steel that the condenser was made out of. And they said, "We'd like to prove this. Can you help us prove it?" So there were three things that we wanted to do. We wanted to come up with an analytical hypothesis. We wanted to come up with some empirical data to show that the hypothesis was in fact correct, and we wanted to have a solution to resolve the issue and not have hexavalent chromium. To come up with an analytical hypothesis, you want to show mathematically what you think is happening. And we sat down and looked at the gas stream that was coming in, which was a mixture of phosphoric acid and water, and said, okay, look, the phosphoric acid is hitting these front tube fins on the heat exchanger. It's reacting with them because it's condensing on them, and it's dropping out of the stream first. And based on our mathematical model, which was comprised of the physical chemical properties of the stream that was coming in, the physical properties of the condenser, and the temperatures that were used in the cooling water of the condenser, we determined that the phosphoric acid should be dropping out by the 6th row of tubes. And the next step was to actually prove that. Now, there's only one way to prove it quickly, and that's to get your hands on a condenser. The unit that they were cleaning was too far away and needed to be put back up online. So their customer service group was able to locate another power plant that was going through its routine maintenance of another part of the power plant, the cell stack, and said, look, you can swap the condenser out of that one, but you're going to need to do it this weekend. So now we're into the gun. We got to get another condenser lined up so we can get out there, swap the two things out, and get it back for analysis. That turns out to be a little bit more of a hassle when you're doing it on the weekend. We were lucky we were able to get some welders up from Newport News, Virginia, and we were able to get a trucking company that would meet us on site. There was a crane already on site. This unit weighs over 1,500 pounds, so you're not going to have a couple of guys just lift it out, but you have to take off the major panels that are surrounding it. You have to get in there with a crane, which was on site. You will in for the day when it is. And you have to have the right strapping to pick it up, and then you have to have a large enough truck to put it on. All of which needs to be done in a series of 24 hours. You have to come up with all this information within 24 hours of how you're going to do it and how you're going to get there, who's going to do the cutting, who's going to do the lifting, who's going to do the shipping, and someone needs to be there to make sure it's all done right. And that was me. But it all had to be done on a Saturday and a Sunday. Or Sunday. So we get out there on Saturday, everything goes smooth, no problem, get the unit on the truck, get it back, pull it out, things covered in green hexavalent chromium, and long story short, they cut the condenser down the middle, they took one look, and all of the green disappeared by the 6th row. Yes, the hypothesis was correct. We now had empirical data to show that. The solution was actually fairly easy to come up with. You just did some material selection and used G30 Hastelloy on the front 6 or 7 tubes, and you weren't going to have any hexavalent chromium. The phosphoric acid would condense out, and you put some sacrificial iron on the bottom of the condenser, and that would react with all the phosphoric acid harmlessly. So a little more expensive to build the condenser, but it doesn't create a cancer-causing agent that needs to then be put in a chemical landfill. So it was a happy ending, not bad, and got all done within